So we've been using the term respiration quite a bit in recent lessons. Let's see if we can kind of determine what we mean by it. So I think, first of all, we need to consider how energy is kind of utilized within systems. And let's think of it within human systems for now. So let's take energy and then let's think about what it contributes. So first of all, we could certainly say, and we're going to look at numerous examples of this in this tutorial, that energy is important for something like movement. Think about movement as muscles contracting and pulling on bones, that kind of skeletal muscle involvement. Of course, energy is required for the production of force in that sense. Okay, so that's really important we think about it in that context. Secondly, you might want to think about energy in something like keeping warm. Or indeed, we might say regulating temperature. In fact, let me put that as a term. We could even refer to aspects of this as aspects of thermoregulation, regulating temperature. So keeping warm, energy is required for that particular process. We're not going to get into the details of it now, but generally speaking. But this one's a really interesting one. We can also think that energy is required for chemical reactions to build larger molecules. And you're probably thinking, hang on a minute, that sounds a bit more complicated than the others. But this one here is what we'd loosely refer to as metabolism. Well, not loosely, exactly. And we'll come back to that in a future tutorial. So these are some examples and some really central features of what energy is required for. Now, I want to make a sort of a distinction at this point, and the distinction is this one. Let me choose a nice lilac. Energy is provided, and let me change color here, by cellular, easy for me to say, cellular respiration. I nearly said cellular respiration. Why is it so hard to say that? Cellular respiration. Let me say it in my BBC voice. Cellular respiration. Didn't come out, did it? Anyway, so energy is provided by cellular respiration. Let's move on, shall we? And I also want to say to you, respiration. Cellular respiration. Oh my God, this is so embarrassing. Respiration is an exothermic reaction. Why is it an exothermic? Why is it an exothermic reaction? Well, because it releases energy. That's the essence of it. And again, we looked at, for example, photosynthesis as a process. That's endothermic because it takes energy in order to produce that glucose and the oxygen gas. And this is really important. I want to stress this point to you. Respiration. I'm seriously considering giving up on this video because my words literally will not come out. Respiration takes place continually. So a couple of key ideas for you there. Continually in all cells. Well, let's put it like this: in all living cells. And we're going to look at both aerobic and anaerobic forms of respiration with this tutorial. But can I also stress to you that aerobic and anaerobic respiration don't necessarily happen at different times. They are concurrent. They happen at the same time. You often want to think about aerobic and anaerobic respiration as which one is predominant, which one is contributing more energy, and therefore we'd say that tends to be aerobic or it tends to be anaerobic. With that in mind, let's actually move on to aerobic respiration. Now, have a look at these images here, why I've included them. We got on the right, someone's going for a bike ride and it's been raining and they're in the forest and it's muddy, but ultimately, although they're pedaling here, they're doing work which is kind of like moderate intensity. They're not sprinting as such, okay? And that's one feature you might want to sort of reflect on with regard to aerobic. Secondly, we have this one on the left here, which is not just some people going for a walk on a big sand dune or in a desert. This is the Marathon des Sables, hundreds of mile long endurance event based in Africa. I can't remember exactly where. And these people run, walk, move for hundreds of miles, I think over 3 days. And it's, of course, relatively low to moderate intensity, but very, very long. And some of those features are important for aerobic respiration. What I want to do, however, is I want to give you how aerobic respiration occurs. So let's put the word equation in first. We've got glucose plus oxygen glucose plus oxygen, goes to, and there are numerous enzymes involved in this, but I'm not going to get into them today, goes to, whoops, carbon dioxide, so carbon dioxide gas, and water, and, although I think the chemists might get a bit upset at me for actually including this on the product side, and energy. And I'm going to put my energy somehow in some kind of squiggly something or other like that, just to stress that point. So again, just to clarify what the situation is here, let me just break this down as a symbol equation for you. I'm probably not going to be consistent with my symbol colours that I've had before. So glucose is C6, H12, O6, and that in combination with, let me keep my colours consistent at least here, H2O. Sorry, what am I doing? I'm so sorry, I hope you were telling me I was wrong, guys. In the presence of oxygen, or oxygen gas, goes to C, O2 plus, we'll get it right this time, H2O. Now, I'm not going to balance my symbol equation up. I encourage you to do that yourself. It's not difficult. You can have a little go at that. But I want to make a couple of other critical points here that I think are really, really important. This method provides lots of energy. And the reason it's able to do that, and therefore we consider it to be quite efficient, is because glucose is fully oxidized. So for each glucose molecule, we fully oxidize it. And as a result, it's fully utilized within this reaction, which you're going to see in a moment is not the same with the anaerobic system. And the other point I wanted to remind you of is just be reminded that this happens in mitochondria. So those organelles within all eukaryotic cells that are the main site of respiration, well, now we're seeing it. This happens within those mitochondria. So just a couple of reminders. I mean, I don't think you're necessarily going to get asked about this, but we're talking about something in terms of energy. We're talking about for movement. If we think about movement, it would produce kind of moderate intensity, and it's capable of long duration because we fully utilize that glucose molecule. So therefore, you might want to start to think about maybe sports you do or activities you like or things you watch on telly. You know, things that are long duration and not sort of like power sprint based, they're probably going to be primarily aerobic in their nature. Okay, fine. Let's move on. Let's think about anaerobic respiration. You see, first of all, that the nature of the activities I've got in the image is quite different. These are explosive. Talking of explosive, maybe I should spell that right with an A in the middle. My goodness me. An A, so just I'm going to rewrite that for you. Anaerobic. Wow. But you see these images, we've got a pole vaulter, we've got what appears to be a 100-meter sprinter. These are power-based kind of activities. All right, now I want to break this down for you. Okay, I'm only going to give you a word equation for this one, although there's nothing to stop us really looking at the symbol equation. I just don't want to distract you too much. So glucose without the presence of oxygen, so therefore anaerobic, goes to lactic acid, which I'm sure you've heard of, lactic acid, plus, and again, I'm sort of being a little bit creative here, and again, these chemists might not really like me for it, but plus that energy concept as well. And that energy it's a utilizable form of energy that can be used for things like movement. Okay, so a couple of things that I would stress to you are super important about this system. It releases much less energy. Much less energy. Okay, so that's really important. So we could consider to be less efficient, might be a way of putting that. And the reason that is because we get the incomplete oxidation of glucose. So, I mean, a nice way of thinking about it is that this lactic acid thing, we're not going to get into the details of it here, this is actually not that dissimilar to glucose. It still has a bunch of carbons, it still has a bunch of hydrogens, it still has a bunch of oxygens. So as a result, this can actually be later processed in numerous ways to be reconverted as an energy store, actually, or utilized for energy. So we're only stripping this glucose of some of its potential. Okay, and that's where this potential is here. So that's a nice way of thinking about it, but we'll obviously get into the details of that perhaps another time. Now, I did mean to clarify something. This is anaerobic respiration in muscles, I should say. So this is really for movement, what I've just described to you. Right, let's look at one other thing. Let's look at oh my goodness me. Let's look at anaerobic respiration in plants. Okay, because anaerobic respiration also occurs in plants, but there's a different structure. This time we have the presence of glucose. Remember, glucose is a product of the photosynthetic reaction. Glucose is converted into ethanol. You can think of that as alcohol, if you like, plus carbon dioxide, plus our energy. Okay, so we first of all need to recognize that this is a process of fermentation. All right, so this is, well, couple of things I'd say. First things first, let me choose a nice happy color. So here we've got no requirement for oxygen, so no O2 required. Okay, so that's the first thing. So that is the nature of this anaerobic reaction. And secondly, we can call this a process of fermentation. And I mean, I'm not going to get into the details of this today, but if you even think about that fermentation, this is where alcoholic drinks, for example, beer or wine, you know, I've got some grapes up here, for example. This fermentation can actually lead to the production of products that human beings actually use and many enjoy. Now, I would also stress to you here, I've mentioned in plants here, we should also mention that this is in yeast cells also. So if you think about yeast cells and some of the uses of yeast is used in various things, not least in beer, but if you think about yeast in bread, for example, so think about a nice fluffy kind of loaf that you might enjoy eating or having part of your sandwiches or something like that, it's important to realize that yeast releases in exactly the same reaction. Yeast releases CO2 bubbles to make bread rise. So that is a really interesting application of this particular anaerobic biology.